We're looking at the MAC 1140 pre-calculus worksheet for piecewise defined functions with domain and ranges. We're going to start with question 1, which is asking us to create a graph for the following piecewise function. F of x is equal to 3x minus 2 if x is greater than or equal to 2, x plus 3 if x is equal to 1, and the absolute value of x minus 5 if x is less than 1. So let's go ahead and start off by obtaining the graphing plot points for each function. So I'm going to go ahead and color code them. First one is going to be blue, second orange, and third green. So let's go ahead and make XY tables for each of them. So starting with our first table for 3x minus 2, let's look at the restriction. We know that it can be this function if and only when x is greater than or equal to 2. So based off of some x values on that, I'm going to start with 2. We're going to go all the way up to 6 for this one. And we know that the start of this is going to be a closed dot because it's greater than or equal to. So next we'll move on to the second function. And we know that the only way that it can be x plus 3 is when x is equal to 1. So there's only 1 for this. Now the x values for the next one. We know that the x values for this function will only be true if it is less than 1. Now I'm going to go ahead and put a 1 here anyways, even though it's not included, so be sure that if you're going to graph this point, it has to be an open circle, because this point is technically not defined since it is outside of the restrictions. So for these, I'm just going to go from 1 to negative 2. So for these, I'm just going to go from 1 to negative 4. So now that we have all the x values that we're going to plot for each of these, let's go ahead and find their corresponding y values, going back to 1. So all you have to do for these is to plug in your x value to solve for your y. So I'm going to go ahead and do that for our first table. When you plug in 2, you're going to get 2 times 3 is 6, minus 2 is 4, 3 times 3 is 9, minus 2 is 7, 4 times 3 is 12, 12 minus 2 is 10, 15 minus 2 is 13, and then 18 minus 2 is 16. Now for the next one, it's only when x is 1, so 1 plus 3 is 4. Now moving on to our third function, it's the absolute value of x minus 5. So 1 minus 5 is negative 4, 0 minus 5 is negative 5, and then we're going to continue doing this for the x values. Now that we have all our points, let's go ahead and graph them. So for the first function, I went ahead and just graphed the first 2 points because the other ones went off my graph. And this is just going to be a linear function with a line, and it continues on forever in the positive x direction after 2 because it is restricted to that domain. Now the second function is just one singular point at 1, 4, and it's a closed circle because it is equal to. Now for the last one, we're going to graph that first point, the 1, negative 4, with an open circle because it is not defined, because technically speaking, the point at positive 1 is not a point that is part of our domain because it is restricted by the x is less than 1. So now that we have that graph, we can go ahead and determine our domain and range. Our domain is our x values read from left to right, and we know that our domain is going to be from negative infinity, which is an open parentheses, from negative infinity, which is going to be a parentheses, all the way to positive 1, and it's going to be a bracket because of the fact that this is a closed point. And there might be a question on why is it going to be positive 1 if there's an open dot that is not defined right here, but it's going to continue to be defined because on the same exact x point we have a defined circle. So we're going to put a union because it has a break right here. It has a gap where there's no points, no lines, nothing, not a single function connecting that. So that is why we have a union, and we have another bracket because we have a defined circle, a closed dot. It is defined. So that is going to be from 2 to positive infinity because it does not end. That's our domain. And as for our range, you read from bottom to top on our y-axis. So that is again going to be a bracket because it ends at negative 5 and it does not go any lower. And it goes all the way up in the positive direction to infinity. because this line, the green function, continues onward and it does not stop, covering this gap here, and then this one continues on again and it does not stop. So that will be an open parenthesis. So that is going to be your domain and your range and your graphed piecewise function. Now let's move on to question 2, and it has the same exact instructions to create a graph and find the domain and range of our piecewise function. We're given f of x is equal to 5/2 x if x is less than or equal to 0, and x minus 3 if x is greater than 0. So let's go ahead and start by color coding these and making our xy tables for each one. So looking at our functions to determine our x values, looking at the first one, we can see that it is restricted by the fact that x has to be anything less than or equal to 0. So since it's equal to 0 as well, you can go ahead and include that point. You can do anything less than 0. So I'm going to go all the way down to -3 for this one. Now for the second function, it is going to be any value restricted to being greater than 0, and 0 is not included. And I like to include the point that's not included typically in it anyways, just so I can determine my domain and range a little bit better. So I'm going to start at 0, but remember this has to be an open circle, meaning it is not defined on your graph. It is not going to be defined in your domain for that function either. So let's go ahead, I'm going to go up to 5 on this one. So now we'll go ahead and plug in our x values for our first function to get our corresponding y values. Any number times 0 is going to be 0, and then 5 divided by 2 times -1 is going to be -5/2. And then we're going to find the y values for our second function. And now that we have all the points, we can go ahead and plot them on our graph. So starting with the first function, the plot 0, 0 will be the beginning of our graph for that line, for that function. And it's going to be a closed circle because it is defined by the less than or equal to. So once you have our first function graph, you can go and graph the second function, starting at 0, -3. And remember, this is going to be an open circle because it is not defined in our restriction. We can go ahead and plot the rest of the points. So now that we have it plotted, we can determine our domain and range a little easier. So looking at this, we can see on our x values, it continues infinitely in the left-hand direction and infinitely in the right-hand direction. And there is not a stop here or a gap or anything because we have a defined function that ends at 0. So it'll be -infinity to +infinity. As for the range, you can see it continues forever in the negative direction going down and in the positive direction going up. So again, that's going to be from -infinity to +infinity. So now that we have a domain range and what it looks like, that is it.